So at the beginning of this class opener, you need to know the slope formula. If you don't know the slope formula, you're not going to be able to do this. So you have to have this memorized. You're going to have this memorized on the test this Friday. So the first thing to do is to know the formula and then label your coordinates. So number one, let's label our x and y values. So this is an x value, this is a y value, this is an x value, this is a y value. Let's call that first one our first point and the second one our second point. And that's why we put a 1 on the x, a 1 on the y, because that's saying this is our x from our first point. This is our x from our second point, right? This is our y from our first point, our y from our second point. So that's how we label it. Again, you need to know this formula. And you always start out with this. M equals the division bar and the subtractions. And then you plug in your values. Y2 is up on the top left, which happens to be 5. Y1 is -3 on the top right. Bottom left is x2, which happens to be 4, and x1, which happens to be -2. And the reason why we start with the division and the subtractions here and here is that way you could clearly see the minus that you have to change to a plus whenever that happens. Sometimes it doesn't, sometimes it does. So right here our answer is 3 plus 5, or 5 plus 3 is 8, 4 plus 2 is 6. That's your answer, but any fraction that you get as an answer, if you could reduce it, please do so. So both are even, which means we could divide both by 2, and our final answer will be 4 over 3. So our slope is 4 over 3. Again, that means that wherever a point on the line is, you'll be able to go up 4 and over 3, rise 4, run 3 to get to the next point. That would be the slope of the line, the steepness of the line. Same thing, number 2, we need to know the formula. And let's label our points. And then let's start with M equals the division bar and the subtractions. And then let's plug in our values. Y2 is -2, Y1 is 7, X2 is -5, X1 is 2. And when we do the math, we end up with -2 minus 7 up on top. That is -9. And on the bottom, we have -5 minus 2. That is -7. And you can't really reduce 9 over 7. But we do know, Sergio, that a negative divided by a negative is a what? Positive. All right, so plus. So your answer is positive 9 over 7. That's your slope. That's pretty steep. You rise 9 and run 7. Well, it's not that steep, but it is a rise 9, run 7 slope. Jumping to number 3, let's label our coordinates. This is our first point. This is our second point. And now let's start with the M equals, the division bar and the subtractions. And let's plug in our values. Y2 is -5, Y1 is -3, X2 is 2, X1 is 2. Now, what happens here, guys, the minus changes to plus, but more importantly, on the bottom you have a 2 take away 2, which is 0. So your answer is going to be 0 underneath with the -2 up on top. And it doesn't even matter what's on top. If 0 is underneath, what's your slope? Undefined. Again, 0 underneath, slope is undefined. Underneath, undefined. Okay? So we say M is undefined. Okay? M is undefined. I believe you could use this symbol also, but I would just, what was that? If the zeros, yes, good question. If the 0 is in the denominator, is it undefined? Absolutely. If 0 is a denominator, it's undefined. If 0 is a numerator, then M equals 0, right? And I think that's on the next example. Number 4, let's label it, and then let's start our formula. And now let's plug in our values. Y2 is -12, Y1 is -12, X2 is -11, X1 is -7. The minus changes to plus. On the numerator, you're going to have a -12 plus 12, which is 0, okay? And 0, it doesn't matter what it's divided by. In this case, it's -4. 0 divided by any number is 0. So right here, the slope is 0. You could say no slope. Now, do not say M equals that. That'd be undefined slope. That's incorrect, all right? So don't do that. M is 0. That means it's no slope. Visually, what that would mean is that, I'll even graph it for you right here. this would be a flat line crossing the y value at negative 12. 1, 2, 3, 4, 5, 6, 7, 8, not way down here somewhere. It would be a flat line crossing the y value at negative 12. That's no slope. It's totally flat, not steep at all. Let's move on to number 5. Of course, you didn't have to graph the last one. On number 5, they do tell us to graph, and they want us to first write it in function form. Function form means get y by itself, so you're going to subtract 1, which you obviously cannot subtract 1 from a 2/3 x. But we could rewrite it. So our new function form equation is y equals 2/3 x minus 1. And then it says use an input-output table to find more coordinates. So we're going to go with an xy table to get some coordinates to graph this line. So could I use 0? Is it a good idea to use? Yes, always a great idea to use 0. Why? Because when you do 2/3 times 0, it's going to end up being 0, and then minus 1 ends up being your answer, negative 1. Does that make sense? So when you plug in 0, you get out a negative 1. Once again, you plugged in 0 in place of the x, and 2/3 times 0 is 0, and 0 minus 1 is negative 1 as an output, your answer. So that is a coordinate. It's always a great idea to use 0 as an input. Now, is it a good idea to use the number 1 as an input? No. How about the number 2? No. How about the number 3? Yes, 3 is a great input. Why is that? Because we have a fraction in front of x, and that denominator is 3. So when we do plug it in, here's my function, 2/3 x minus 1. There it is, 2/3 x, but I put parentheses minus 1. And when I plug in a 3 in here, it's going to be beautiful because when you multiply a fraction by its denominator, it cancels out, and you end up with 2 take away 1, and 2 take away 1 is 1. Okay? So your input 3 gave you your output 1. Just with those 2 points, we could graph it already. So let's just stop right there. I mean, you could plug in more numbers, like negative 3 or like 6. I'm just going to stop right there. Let's graph the coordinate 0 on the x, negative 1 on the y, and put a dot right there. And let's graph the coordinate 3 on the x and 1 on the y, and put a dot right there. And of course, we have our line. 2 dots is enough. Put some arrows on it. We are done. Now today we're going to learn an easier method of graphing this thing. But before we do that easier method, let's state the slope visually. So how do we look at lines? We look at them from left to right. So you need to pick any 2 points that are nice coordinates. So what do I mean by that? They give you this coordinate right here and this one right here. They want you to compare those 2. But you don't have to compare those 2. You could have compared maybe this one with this one. You could compare any nice points. Obviously, you're not going to pick this one because that's in between values. You're not going to pick this one that's in between values. You want to pick some nice coordinates. And since right here on these red ones, they tell you you're going to go up 2 over 1. Remember, slope is rise over run. Slope is rise over run. It's positive if from left to right it's going up. If it's negative if from left to right it's going down. But we're always looking at it from left to right. So from left to right it's going up how many units? 2 units. It's going over 1. So our slope here, our m, is 2 over 1. Or you could just say m equals 2. I would leave it 2 over 1 though. Rise over run. Now the next one, you could compare this one with this one. Why am I comparing those? Because I could clearly see they want us to. They're telling us from here to here it goes down 1 unit. And from here to here it goes over 3 units. So the rise is negative 1 and the run is positive 3. So the slope is down 1 over 3, negative 1/3. Again, down 1 over 3. So like I said, you didn't have to use these coordinates. You could have picked some different ones. You could have done this one way over here on the edge and maybe this one right here. Comparing those red dots, you would be going down 1, 2, and then over 1, 2, 3, 4, 5, 6. So if you did get that comparison of down 2 over 6, it would still reduce down to that answer anyway. Okay? So you could pick any 2 clean points on any line, count the rise and the run, and you should be able to identify your slope. Okay, so that's all stuff that we should know, and it's going to relate to what we're doing today. Today we're going to learn about a different form, a third form. But actually, it's almost like a previous form, function form, because it is function form. You guys remember what function form was? What is function form? Anybody? Y by itself, right? So right here, y is by itself. So slope-intercept form technically is function form, but there's more details to it. There's more organization to it. What do I mean by that? It's function form y equals, but on this side, there's very specific things. It's mx plus b. And we need to know a couple of things here. Let's all do this. Let's write down, we already know what m is. What is m? Slope. Yep. So the m is just going to be a number, most of the time a fraction, because we know that slope is really rise over run. So whatever number is right here, we're hoping that it's a fraction. That way we'll know the rise and the run. We'll know the steepness of the line. Even if it's not a fraction, you're going to put it over 1 to make it look like a fraction. Okay, so m, we already know it's going to be a number. If it's not a fraction, we can make it look like a fraction by putting it over 1. And that's what this number represents. It represents slope. And this guy over here, b, represents something very important. This guy is the y-intercept. Okay? Not the x-intercept. It's very specific. It's the y-intercept. And just to refresh our memory, what does y-intercept mean? It's where the line crosses the y-axis. So the number that you see over here is going to tell you where your line crosses the y-axis. And believe it or not, guys, if you know where it crosses the y-axis and you know the steepness of the line, you'll be able to graph it without doing an XY table, without having to find the x-intercept and y, without doing any math. If it's in this form, remember, form is just the organization of the equation. It's the way it looks. If your equation looks like this, y equals a number x plus a number, or a number x minus a number, you're going to be able to graph it instantly without doing any math. So this is like one of the most important forms that we need to memorize, called slope-intercept form. Now, why do you think they call it slope-intercept form? Because they show you the slope and they show you the intercept. If it's in this form, you could see the slope, you could see the intercept. Let's see how this plays out. Check it out up here, guys. Right here on the notes, it says, instead of using 3 steps to graphing, remember, function form was step 1, XY table was step 2, plotting coordinates, drawing the line. That's great and all, but this method, y equals mx plus b, is way faster. So if it's not in y equals mx plus b, step 1 would be to rewrite it in slope-intercept form, right? Get y by itself and make sure your x terms first before your number. After you have it in this form, you graph it without doing any math. How do you graph it? It says first go to your y-intercept. So first go to your, instead of y-intercept, you could underline it and put a b right above it. So first go to your b value. Oh wait, it says it right here anyway. You don't have to do that. It says right there, your b. And then from that point, rise and run according to slope. You rise and run according to your m, to your slope. So look how easy it is, guys. Number 1, could anybody tell me what the slope is right there? What's the slope? The slope is 2, and you could make it over 1, so you could have it in the form of rise over run. And how about the b value? What's the b value there?
3.
It's actually?
Negative
3.
-3.
Okay, now, if you're able to identify that, you'll be able to graph it. Okay. Now, let's think about this. Out of these 2 bits of information, what's the only thing that you could actually, or the easiest thing you could plot on the graph right now? Even easier than slope, the b value. What does the b value tell you? Where it crosses the y-axis. Where does it cross the y-axis?
-3.
So all you got to do is go to the y-axis. Here's it says y right here. Go to -3, which is right here, and let's put a dot right there. So everybody go to -3 on the y-axis. Put a dot right there. Now here's the deal, guys. You don't know if we know for sure it passes right through here. It might pass really steep going up, maybe just kind of steep going up, maybe kind of steep going down, maybe really steep going down. So we don't know the steepness yet. And how could we get the steepness of any line? The slope, the m value. So what is the slope? What is the rise?
2.
And what's the run?
1.
So from this point, you're going to rise 2, 1, 2, and you're going to run 1, 1. And you put a dot right here. And guess what? You're done. You have your line without doing any math. Okay? So now you could make this, you just draw your line right through it. And again, if you wanted to make it longer, all you have to do is continue the pattern of your slope, up 2 over 1, up 2 over 1, up 2 over 1, put a dot there, up 2 over 1, put a dot there, and you'll be able to make the line as long as you want. And you just draw a line right through those points, put arrows on it, and you're done. You graph this thing without doing any math, just by identifying your slope and your y-intercept. Number 2, is it in slope-intercept form? No, it's not. So what do I need to do? Subtract 1. Let's all subtract 1. Subtract 1. We're going to rewrite it. It's going to say y equals 2/3 x minus 1. Now that it's in slope-intercept form, you could clearly identify your slope, which is what? 2/3, and your b value, which is what? -1. So how do you start this thing? With the -1, with the b value. So let's all go to -1. Let's put a dot right there on the y-axis. Remember, it's a y-intercept, not an x-intercept. It's a y-intercept. Now, from that point, how much do I rise and how much do I run? Right? You rise 2, you run 3. So let's go rise 2, 1, 2, over 3. 1, 2, 3. Let's put a dot right there, and we are done. Connect the dots. Let's say you wanted to extend it this way. Then you could continue with the pattern of up 2 over 3, but backwards. Down 2 over 3, down 2 over 1, 2, 3. You could get to that coordinate right there, and you could extend it as far as you want. Okay? So, for the sake of time, I think I'm going to pause. I want to end this video right here, and we're going to pick up the next section with the next video.